You know that feeling, right? You're in the middle of the city, it starts pouring rain, and you see all this water just gushing down the street and into the drains. And you've probably wondered, where does it all go? It just vanishes. Well, let's get into it, because the answer uncovers this whole hidden world of natural systems and human engineering, and it's all under some serious pressure.
It's such a simple question, but the answer is anything but. To really figure it out, we first have to understand these invisible funnels that are literally shaping the entire landscape all around us. You see, long before we ever lay down a single pipe or paved a road, nature had its own super effective drainage system. It's called a watershed, and spoiler alert, you're standing in one right now.
So here's the deal with a watershed. Just think of it like a giant basin or a funnel. Every single drop of rain that falls inside its ridges eventually flows down to the exact same spot, whether that's a tiny little creek or a massive river. The basic idea is exactly the same. In this picture, it shows it perfectly. It doesn't matter if rain is falling on a forest floor or on a grassy field, gravity just takes over. It pulls the water downhill, collecting it into bigger and bigger channels. It's really nature's plumbing at its absolute best. So, what happens when we come along and plop our cities right in the middle of this beautiful, elegant system? Well, yeah, that's where things get complicated. We've essentially built our world right on top of these natural highways for water, and now we're squeezing them from two different sides, with our sprawling cities and with our changing climate. Okay, let's break this down. Natural ground, what we call pervious surfaces, it acts like a giant sponge. It soaks up water and releases it nice and slow. But then you have our cities, right? The concrete, the asphalt, the rooftops. They're impervious. They act more like a shield, forcing all that water to just run off immediately. And get this, research shows there's a real tipping point. Once about 10% of a watershed is covered in these hard surfaces, the flood risk starts to skyrocket. Now, what's so fascinating here is how this actually plays out with different kinds of rain. Look at the graph on the left. That's a short, intense thunderstorm. See that huge spike? The runoff in the urban area is almost double what it is in the natural landscape. But now look at the slow, gentle rain on the right. The difference is way less dramatic. So the real problem isn't just rain itself. It's the intensity of that rain hitting our paved-over world. And that brings us right to the second half of this squeeze. Our climate is changing. And one of the biggest effects is that extreme weather. These really intense storms are happening more and more often. And if you really want to wrap your head around that threat, just look at this number. That's over a meter of rain. That's almost 43 inches in a single day. That's 55 times the normal monthly average for that area. Our traditional drainage systems, which were built for the weather of the past, they were never, ever designed to handle that kind of downpour. So what happens? You've got these natural systems paved over, getting hammered by these insane storms. What happens when they finally break? The consequences? Well, they can be quiet, but they are absolutely devastating. It's not just about the dramatic flash floods you see on the news. The real, long-term killer is soil erosion, and this quote nails it. It's a process that can be kind of invisible during a single storm, but when you add it all up over time, the effect is catastrophic. And the damage is really a one-two punch. First, on site, where the rain actually falls, we're losing precious topsoil. That wrecks the land's ability to grow anything. And then, off-site, all that dirt that washed away has to end up somewhere, right? It clogs up our reservoirs, it blocks our drainage systems, and it pollutes our water. And the scale of this problem is just mind-boggling. Over half, 52% of the world's productive farmland is already considered degraded, and water erosion is one of the main culprits. This isn't some abstract problem. This directly impacts global food security and the health of our planet. So facing all this, what was our old way of thinking? Well, it was pretty simple. Fight back. Brute force. We just built higher walls and bigger dikes. But that creates a really dangerous paradox. The higher the wall, the more catastrophic the disaster is when the water does eventually break through. For decades, we've been fighting a war against water, instead of just learning how to make space for it. But this is where the story starts to turn. Because now, armed with way better data and much smarter technology, scientists and engineers are coming up with new ways to understand, to predict, and ultimately to live with the water. It all really boils down to this classic saying. If we want to build cities that can handle the future, we first have to get really, really good at modeling what's happening in our watersheds. But here's the key. Modeling the future isn't about having a perfect crystal ball. It's more like planning a vacation with a weather forecast. You don't know if it's going to be exactly 75 degrees, but you know the range of possibilities, so you can pack for it. This graph shows the same idea for rainfall. The goal isn't to get rid of the uncertainty, but to understand it, to measure it, and to plan for all the different futures that could happen.
And that smarter planning leads to smarter engineering. Instead of just relying on good old gravity, which gets overwhelmed pretty easily, modern siphonic drainage is a total game changer. By using a really clever drain design, it stops air from getting into the pipes. This creates a powerful vacuum effect that literally sucks water away at incredible speeds. It's way more prepared for the kind of intense storms we're seeing now.
All of these new ideas are leading to this huge fundamental shift in how we think about our cities. We're moving away from fighting water and moving toward building a resilient future where we can actually coexist with it. The new approach is called adaptive management, and it's not a one-and-done kind of fix. Nope, it's a continuous cycle. You monitor the watersheds, you analyze the data, you adapt your strategies, and then you do it all over again. It's about being nimble and constantly learning and adjusting to a world that is itself always changing. This has given us this incredible new toolkit to work with. We've got ideas like low-impact development, which is basically a fancy way of saying we're designing things like green roofs and permeable pavement to turn our cities back into giant sponges. We're using soil and water conservation techniques that use plants to hold soil in place. The real key is mixing all of these solutions together to create a layered defense that's way stronger than any single wall could ever be.
So at the end of the day, it all comes down to this one question. Those unseen rivers flowing under our feet, they aren't going away. And the storms coming from overhead, they're only getting stronger. The real challenge for all of us is to design cities that are smart enough and maybe humble enough to make room for the very water that gives us life.